Welcome everyone. Today is January 4th, and this is another of our bi-weekly batch work group meetings. My name is Mattia, and I'll be your host today. We have two topics on the agenda. Francesco will be the first one to talk about rescheduling pods. Take it away from here, Francesco.
Hello, everyone. So I put together a couple of slides, but they're not really critical. I can show them, but they're not like super critical. So I guess I will just start talking. Let me try sharing. Thank you.
Yeah, I just did you a co-host, so you should be able to.
Awesome. Thank you. Let me try use system window capture. Share. Should be this one. And it should be showing.
Yep, we can see your slides.
Awesome. So basically, the proposal is make sure the kubelet can trigger a flow which enable rescheduling of the pods. So what's the elevator pitch? If the kubelet determines somehow it cannot run a pod, instead of just marking the pod failing and trigger and send events for observability and send logs and whatever, make a trigger mechanism to, okay, let's retry rescheduling the same pod versus keeping it in a final state. Now, the first question I would expect before why probably is how come the kubelet cannot actually run a pod? Turns out that there are few well-known cases that if those cases are hit, they cause non-trivial headache on which, despite the scheduler, for example, best efforts, the kubelet cannot actually run a pod. Then the easiest example I can think of, because I work quite a lot in this area, is that we are requiring, for example, NUM alignment in Topology Manager because the kubelet is configured so, and we are requiring strict NUM alignment. The scheduler doesn't do accounting with the NUM granularity, which is another topic for the normal scheduler. But in these cases, you can get topology affinity error and no luck. Now, from initial feedback, there are quite a bunch of some user cases from the runtime, because we want to shift more and more responsibility on the runtime on which, okay, the runtime is setting up things and it cannot do that. Yes, this is light on details, but as we will say in a little while, we are still in the experimental phases. We are still, this proposal is very fresh, so details will come. And the device plugin are another source of which, okay, this device could not set it up and there is no hope of setting up shortly. So possibly to have better user experiences, better to try on another node rather than set the pod in failed state. And another area which we are currently exploring, again, was very fresh, is CSI and storage access. Now, why I'm saying this proposal is very fresh? Because after some conversation at KubeCon North America in the context of DRA beta graduation, this proposal came out. We later figured out that this is actually not needed for DRA beta graduation, but still this proposal caught the interest of quite a few people, and it's actually beneficial for quite some use cases. And this is why I'm bringing this up. And the place on which we are is that we completed the first draft of the design doc, but before investing significant resources in this research, here we are talking with the community and gathering like initial feedback. So another question which I would expect is, okay, nice, could be useful, but what about the scheduler? And okay, admittedly, I'm still looking to that to be 100% sure what I'm saying is correct. But the very first issue I see with the scheduler for this use case is that first of all, we are talking about the case in which the pod is not yet running. It's tried to go running, but it's not there yet. And on top of that, when we actually hit these cases on which the kubelet say, hey, I cannot run this I cannot honor your request, you have a race with the controller. This is actually a well-known issue filed against Kubernetes, which I linked, which is, okay, the controller, for example, the deployment controller is constantly creating new instances to make sure that, you know, the expected number of replicas are met. And the kubelet is responding, no way, no way, and you end up with a bunch of pod which are in failed state. And the scheduler will have to race with those controllers. So to some extent, a bunch of failed pods, and to a delay, we will always get that. But this is my early assessment. We are still, again, referring to that. So the takeaway is that we can possibly go do some work in this area, but it doesn't seem the best approach. The best approach seems to be with some native changes, which I'm going to, which I explained with the great help from other community members, people from a couple of startups, people from Intel also, they are contributing. So we have this design draft ready, and which was completed mid-December, right before the holiday shutdown and the holiday break. So very, very fresh. And we are reaching out to the various community to talk about that and to get feedback like, hey, nice, maybe we can do that, or no way, no way we will do that, or any other in between. Last words I have is that depending on the feedback and depending on how the 130 capacity pan out, because I have some work which I plan to do in the node area, this may or may not turn out in a cap for 30 or 31, or not at all if the feedback is like, hey, thanks, but no. So with that, this is the pitch, and looking forward to feedback and comments.
Aldo, you had your first hand up.
Thanks. So just to add to the why this scheduler is not an option, and
Yes.
also, I guess another option is just trust the pod recreation, right? Because any failed pod will be recreated.
Absolutely.
By, well, assuming you're using a workload API. But what I wanted to say is that neither of these options are sufficient, because the pod might be created and it might land again on the same node.
Yes.
Because the scheduler is, at least for a small enough cluster, is deterministic. So it will most likely go into the same node if nothing else changed. So we still have the same problem with the scheduler or with trusting the pod recreation. So yeah, just wanted to clarify that.
Yeah. Thank you, first of all. Thank you for your feedback. Thank you for your comment. This was really a wide tour. In the design doc I linked, there are some more details, which, for example, a key detail which I didn't mention explicitly is that among the first design we have is, okay, let's keep a short list of the recently tried node, exactly to enable the scheduler to say, okay, let's not just retry the same node. So more details in the design document. Thanks.
Swati, you are next. Go ahead.
Yeah, thanks, Francesco, for working on this. This is certainly very interesting. So one question I have is related to kubelet. So we are saying that, you know, in scenarios that a pod fails at admission time for, say, cases where resources cannot be allocated, how do we determine that it's a permanent problem that would not resolve itself versus something temporary that would potentially be taken care of? So an example that comes to my mind is, say, device plugins, and you mentioned that in your slides. You know, there could be scenarios where a pod that is requesting a device cannot be admitted because the device is unhealthy, but eventually it could become healthy. So in those kind of scenarios, we essentially have to just wait, and attempting to reschedule the pod could be an overkill. So I'm curious what you think about scenarios like that and how we would handle something like that.
Thank you for your comment. Yes, this is a very important use case. And yes, there is also an issue filed, if I'm not mistaken, by Clayton, about the kubelet should retry to run pods if we hit retriable conditions, like, for example, device plugin unhealthy, but in the issue, there are more cases. And thing is, there are cases on which, okay, the failure is temporary, and we can retry without doing any changes, like, for example, unbinding the pod. And there are cases in which, hey, unless some pod goes away, no chances to do that, to actually admit or get a pod running. This has to be evaluated at kubelet level on case-by-case scenario. For example, device manager, which is a component by kubelet, could say, okay, if the device is unhealthy, I'm not opting in this flow. On the other hand, topology manager, which is another kubelet component, which is in charge of aligning the resources, can say, okay, with this resource allocation, which only the node could know, no way I can run this, so I'm triggering this flow. So long story short, we will need to evaluate, unfortunately, or maybe likely, on a case-by-case scenario inside the kubelet when we implement this change. But the only thing which I want to clarify, and I'm done, is that, hey, not all the kubelet rejection should trigger this scenario if we implement this change. Some of them would, and some of them, it's going to be a balancing act. So this is how I see for myself.
And you see that we would potentially decide based on what component has what kind of behavior, as opposed to maybe the user kind of engaging in the process.
As I stand now, which is of course open for conversation, I don't think the user should ever say this behavior should be granted by the subsystem of the kubelet. Future extension maybe, but as first draft, I don't think the user should. Well, besides of course enabling the feature with a feature gate or kubelet flags or whatever flags, but for example, no pod attribute should say, okay, I want to be, should be a system behavior, which, okay, could be configured, but not like the pod should trigger that. Some pod attribute should trigger that, or annotation or whatever. At this point in time, very open for conversation though.
Sure, makes sense. I think this is something that we should keep in mind when we are kind of thinking about this in general, because I'm not fully convinced that for, say, device plugins, it makes sense to always not reschedule, because there could be scenarios where, you have occupied all the resources and the best way to go ahead is to reschedule. So I'm just kind of having this conversation and thinking out loud on what probably should be the best way to go.
At this point in time, what I envision is that review of the flows in which could be interested in to trigger this behavior and do code changes accordingly for first step. So, but again, we are very fresh. We are just beginning, so we are totally open for conversation.
Martin, you're up.
Thank you.
Okay, so I have a question about like a slightly bigger picture. So pods rarely come alone. Usually they come in groups. So if a node reject as a pod, chances are that the very similar pod, like the next in the group, will get to the node and will be rejected, and so on, until all the pods from the group are rejected by the node. Do you foresee any mechanism that would prevent trying every single pod on a node from the group that is problematic?
Thank you for the question. The answer is no, because at this point in time, we didn't talk about pod groups, but this is a great point, and this is something we should totally explore. So at this point in time, I don't have an answer, but besides, yes, we should look at that and take these use cases in account.
And the second thing is, did you think how it would work with auto-scaling?
The only thing which I can say at this point in time is that we totally want to work, we want to make it work with auto-scaling from day one, correctly. Did we explore, for example, vertical pod auto-scaling? No. Do we want to do that? Yes. Horizontal pod auto-scaling? Same answer. We should, we need to make
more about cluster auto-scaling, where the fact that pod could be scheduled on node, but in fact it cannot be because a node rejected could be problematic because then the scale up may not be triggered. And a new node would not be provided. And the question is, if
Yes.
a node that is very similar rejected pod, is there a chance that the exactly same type of node would accept the pod? So does autoscaling make any sense in case of like a node rejecting a pod? Should we try another one, or what exactly?
Again, okay. So the answer is cluster autoscaling. I didn't thought about it. So this is another point we need to explore. Thanks for raising.
Okay. Thank you.
Abhishek, you're next.
Yeah, I put a question in the chat too, and my use case is regarding gang, and it comes from the other way around. Like if a pod inside a gang fails, then you don't want to retry it, but you want to cancel the entire gang. So I just want to hear a few thoughts on, have we thought about how we can cancel gangs when one of the pods inside the gangs fails to start up?
No. This is another topic we need to explore, which I'm taking notes, by the way. And I feel that we will need something somehow in common with to handle pod group and gang, even though the behavior will be different. But to take into account related pods, this is the theme which I sense from the feedback, is something we need to explore before moving forward and to flesh out.
Right. Thank you.
Thank you for the feedback.
I quickly skimmed through the proposal before the call, and I might have missed something. But in the discussed alternatives, all the proposals, including the alternatives, are heavily affecting the core pieces of Kube, especially the main proposal. It basically goes through API, scheduler, and all the way down to kubelet. I was wondering, have you considered an alternative which is somewhat similar to the one with pod scheduling context, but to the point where you would be able to build the entire mechanism outside of core Kube, meaning that the DRA at the kubelet side of things, usually the device manager is an entirely separate part of kubelet. And if that would mark the pod, or you could create a third-party resource that will provide hints for the next rescheduling of pods from a particular group or a resource. So this way you would basically provide the hints, and then the scheduling when the pod is failed basically would be requiring a third-party scheduler or a plugin to the scheduler that will know how to read those hints and schedule those accordingly in the next cycle. Something like that would allow you to at least test the solution without the changes that are so deep in the core Kube elements.
Okay, thanks for the feedback. Short answer is no, but the long answer is no. Again, only because the proposal is very fresh. For myself, I don't think it must be, it changes core Kubernetes so deeply. True to be told, if we can make it happen with minimal changes, some changes I reckon would be needed. But with minimal changes, I will be absolutely in favor of it. So this is totally another topic which we want to explore as soon as possible.
Stephen, you're next.
Thanks. Yeah. Is there a mechanism? You mentioned that nodes get added to a list so they won't be retried again. Is there a mechanism for those nodes to get removed from that list?
At this point in time, we were considering adding a TTL, time to live, for the entries on the list, and to have a cap size for the list, for to avoid having objects too big. And so no explicit removal, but if we hit a pathological case to which, hey, still not running 10 tries, 20 tries, 30 tries, the idea is to have the entries expire and to have a limited set of them. No explicit removal at this point in time. When we see a strong use case for that, we may think about it.
Sounds good. And is there an opportunity to do sort of like maybe like a two-phase commit where the scheduler asks the kubelet to validate that the pod can actually fit before actually admitting it?
Okay, when too many years ago, because a few years were passed, when we were talking the initial stage of the NUMAware scheduling proposal, that approach was explicitly ruled out. Now things may be changed, and this is something I will probably inquire, but I for myself, I'm not too much a fan of it, because I think the model which, okay, the scheduler does its best and sends a pod toward a kubelet, and the kubelet rarely rejects. So pretty much I'm taking responsibility, working under the assumption that those rejects should be rare occurrence, not like, hey, try, fail, like 19 or more, 99% of time it works. The scheduler does a good decision, and we handle those rejects. So for this reason, this two-phase approach doesn't sound optimal to me. But once we are a bit more like proof of concept, some tryouts, we may want to discuss that approach if it turns out that those rejections are actually more complex. But again, for the moment, the working hypothesis is that, those rejections are not that common. So we are kind of shape the proposal at this point in time, considering that.
Yeah, makes sense that it depends on the base rate. Thanks.
Does anyone else have any other questions? I don't see any hands up. Okay, hearing none. Thank you very much, Francesco, for Aldo, go ahead.
I guess the most important stakeholder here is Signode, and I don't see many comments from Signode other than...
I can comment about that. I presented the pitch last meeting, which was a couple of days ago, but there was very low attendance. So I'm going to present again to get the pulse of Signode as soon as there is a good enough audience. For what is worth, from the very limited audience, the comments were positive, like hey, sounds like a good idea. But the sample size was too little, so I'm totally going to ask again.
Excellent.
Thank you.
Just for the record, myself as a TL46 scheduling, I also think that we need a solution along these terms. Just need to make sure it scales, it accommodates groups of pods, and yeah. But I didn't read the proposal yet, so I'll have a look.
Just a quick question. The general feedback I gather seems to be, yes, this is something we may work on, not like measure blocker or measure design concept. I'm talking about the concept, not the implementation. Of course, will need a lot of iteration, but the concept seems to be like, okay, we can try, right?
Yes, from me.
Okay.
I see John raised his hand. Go ahead, John.
Yeah. Hi, everybody. So yeah, I would agree with that characterization that it seems like a reasonable thing, but I would hope that we can. But what it hints at is deeper issues with the information that's available to the scheduler. And I think this was what was just raised. Like, things that we know or could potentially know ahead of time. It would be good if we could publish that information for the scheduler and for the cluster autoscaler and other components of the system for troubleshooting, to be able to make decisions without a sort of late failure, which is effectively this is a mitigation for late failure on information that theoretically we could know ahead of time, right? It's not like a runtime failure. It's a detail, it's a level of granularity that we didn't publish or make available to the rest of the system. So I think it's hinting at a bigger problem. That doesn't mean we don't mitigate this problem now, but I'm hoping that we can look at that larger problem and look for potential ways to solve that.
It's a very good feedback. Thank you.
Aldo, you're up next.
Yeah, with that comment, I think this is something I would like to call out with regards to DRA, because DRA has this problem of not giving enough information to the scheduler. So what I think it was said earlier that the failure rate should be fairly low. So and I think we need to keep that as it is. We need to keep the failure rate from the scheduler as low as possible, and for that we need a solid DRA design. And in the topic of auto scaling, we probably want to have guarantees or certain level of confidence that a new node would be able to fit the pod, so that we don't have to guess auto scaling. And that again comes with proper information given to the scheduler. I think we can 99% of the cases take a good decision and only use this rescheduling for the other parts, the outliers.
Patrick, go ahead.
Yeah, well, Aldo just said that DRA doesn't provide enough information to the scheduler. I'd like to point out that for the normal flow with a DRA controller allocating resources beforehand, before a pod gets scheduled, we shouldn't get into a situation where it then can't run on the node. So in that sense, DRA already tries to solve this problem of a pod being stuck on a node. It depends a lot on how DRA controllers from specific hardware vendors actually implement their allocation. DRA can't control that. It just provides the mechanism. So if someone implements a DRA controller or DRA driver that still can fail on a node, this descheduling would be useful for them, but it's not a general problem of DRA itself. If implemented as intended, just my 2 cents here. I think we had identified some cases where it would be useful to have this, but it's not as generally useful as for, say, for NUMA alignment, where things just are outside of control of any particular driver. And even there, we could have something like a meta controller. We discussed some cases for that. Anyway, just wanted to point that out. And I fully understand the concern about autoscaling, where we don't have a fallback mechanism. We need numeric parameters, but that's something that is being worked on.
Abhishek?
Yeah, I'm just trying to comment on the topic of giving proper information to the scheduler. But please correct me if I'm mistaken. I mean, by the time the kubelet starts doing its thing, like pulling its image and all, the scheduling cycle has been done. And what in my mind is, what we are trying to do is, we are trying to make sure the scheduling decisions that we have done um, enables the container to be started on the node. So I just want to understand that point, like, giving some metrics a priori to the scheduler, how will that help the scheduler reschedule or retrigger the scheduler scheduling again?
If I understood the question, I mean, I don't think we're talking about metrics. We're talking about decision-making data, right? So I mean, it's sort of people are talking about NUMA-aware scheduling. Like there should be. What I'm suggesting is that there's a deeper problem with our sort of, you know, the schedulers become insufficient to the use cases that we need. That the information available to it to make its decisions are too crude. I'm sure I'm not the first one saying this, right? It's just that what we're talking about here are effectively workarounds to that problem, and you know, I think we as a community need to work on both the workarounds in the mitigations for the short term and the longer term. How do we make the scheduler better, or do we need an alternate scheduler? Do we need a way? Are there new concepts here that we haven't talked about to address this sort of problem that's cropping up in a few different areas? Like we're just late. We want to decide as early as possible that something's not going to work, because all we're doing is creating a lot of latency and a lot of churn if we have to wait for a failure. So anything that, you know, if a machine fails, you know, okay, there's not enough available CPU or whatever, but if we already knew ahead of time this isn't going to fit, it doesn't make sense to have ever scheduled it to it, right? So it's just a matter of publishing the data necessary for that scheduler and having that logic available. And maybe it's too complicated. Maybe we can't do it, but I think we should open up that door. And maybe I haven't been involved in sync scheduling, and maybe it's already been looked at and rejected. I don't know. I'm just from a broad sense, you know, hearing a theme and trying to point it out. So it's not about metrics and that, but it's more about making decisions ahead of time.
I see. Okay. Yeah, this is worth exploring, and it's an interesting thing to design and brainstorm. Yep. Thank you.
Cool. Last call for last minute questions about this topic. Okay, hearing none. We're gonna jump to second topic from Aldo. Aldo, go ahead.
Yeah, I don't need the screen, but if you can just share the link. Basically, we've heard from people in the West Coast that they will wish to participate more often in the meetings, but it's too early. I think right now it's 7 a.m., right, for the West Coast. Certainly some people make the effort from time to time, but it's not ideal. Now, there was an open doodle to come up with a proposal, with a time. Although, unfortunately, I didn't notice any participant from APAC. So I don't think we can go with any of these times as they are. Unfortunately, they seem to be too West Coast specific. So I'm trying to gather information from people in APAC, China, Japan, Australia, to see what is a reasonable time. Now, the additional problem that I see is that it should be at least one of the organizers that needs to be in the meeting. So my thinking is that if we can make it once a month or something like that, where it's like too late for the organizers to host regularly. But if we have a rotation, then each organizer could show up, 10 p.m. their time or something once per quarter or something like that. So maybe that's an acceptable thing. I guess I would like to hear from Maciek, Swati, whether that you think that's something that is doable.
I don't have any objections. I've been attending either early meetings or late meetings. So for me, as long as it will fit folks that we are trying to target this with. I don't mind doing like once a month or whatever the turn will be for me to do it, and join either late or early calls if that will help other folks to participate.
I guess early would have to be something like 5 a.m. or something, at least for me. I'll still explore that possibility, but I think most likely it's going to be late.
Yeah, I just want to echo that sentiment again. Like, it's very important for us to be inclusive of everyone. And I saw some of the emails which said that they seemed that they were excluded from some of these meetings is the last thing we want to do. So let's try to rectify this if that requires us to attend a meeting once in a while at late hours. That should be okay for me as well.
Maybe it would be worth just reopening the doodle and starting afresh and making sure that the folks from APAC region are the primary responders.
Yes. Okay. I'll first try to get a sense of what is early, what is late enough. Like, we already know that people from the West Coast don't want to wake up at 7 a.m. or don't want to show up at 7 a.m. I don't know if 7 a.m. is acceptable for APAC members. But I guess most likely we'll have to target something like 8 a.m. Their time. John?
Yeah, I don't mind getting up. I'm up early anyway, but for other folks on the West Coast, I find in my community meetings that 8 a.m. is difficult because a lot of people take their kids to school during that hour. So the 7 and 8 are generally not great. And it's starting at 9, or even for me personally 8:30, but I know other people 8:30 is still too early from when they get their kids to school. So that's just, I don't have any specific people I'm thinking of, but it's just been my experience in community meetings. Often 8 o'clock's a difficult hour as well, unfortunately.
Okay, so for early risers, 7 a.m. is good, but 8 a.m. is not.
Yeah, well, actually, 7. I take my kids to school 7:15 to 8:15, so both hours are screwed.
Oh, okay.
But that's just me.
Okay, that's useful feedback. Although I think most likely for PST will be afternoon. So we would have to check with APAC folks what is acceptable. Yeah. Okay. So I'll keep thinking about this and proposing a time. But I guess to start monthly seems reasonable.
Yeah, definitely.
Yep.
Okay. All right, that's all I have for this topic. Thank you.
Cool. Thanks a lot, Aldo. And with that, we can call it a day, 4 minutes prior to our usual finish time. Thank you very much all for very delightful conversation, and enjoy the rest of your day. See y'all.
Thank you. Bye bye.